This is section 11.5, Sums of Arithmetic and Geometric Series for Mr. Liao's Algebra 2 Trig class. And today we are going to look at how we find sums of arithmetic and geometric series. So yesterday we looked at sums, series, and sigma notation. You're going to be applying that knowledge today to find the sums of arithmetic and geometric series. Yesterday we looked at how we use sigma notation to write the sum of series. Today we're actually going to compute the sums. Now if you only have a few terms, adding them together is pretty easy. You just add them up one by one. But what if you have a lot of terms? Well, let's suppose we have this series. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. Now if you notice, this is an arithmetic series with a difference of 2. The first term is 1, the last term is 15, with 8 total terms. If we add the first and the last term, we get 1 plus 15, or 16. Now if we move on to the second term and the second to last term, we get 3 plus 13, which also equals 16. You can continue with this pattern all the way until the middle. And you notice you have exactly 4 sums of 16. 4 represents half the number of terms. And you multiply that by 16 and you get the sum. So we can use this formula to find the sum of any arithmetic series. We add the first and the last term, which we will call t1 plus tn, and we will multiply that by half of n, or divide that sum by 2. So, the sum of the first n terms of an arithmetic series is n times t1 plus tn over 2. So again, you add the first and the last term, and you divide that by 2 and multiply by n. n over 2 represents how many times you have to add up that sum. So let's take a look at example 1. First, find the sum of the first 20 terms of the arithmetic series 8 plus 5 plus 2. So first of all, we probably would need to know what the 20th term is. And this is an arithmetic series with a difference of -3. So the first term is 8. We can figure out the 20th term by using the formula to find any term of an arithmetic series. So we plug in n as 20, we plug in d as -3, and we see that the 20th term is -49. Now it's just a matter of plugging it into the formula. We have 20 terms, 20 is n, the first term is 8, the last term is -49. So we add 8 and -49 together, multiply it by the number of terms, which is 20, and divide it by 2. And you do all that, you get -410. Now, even if you don't remember the formula, you can still reconstruct the formula by using the idea that, hey, if I just add the first and last terms, the second and second to last terms, and move my way in, I can figure out what the pattern is to try to come up with a formula. So you don't feel like you need to memorize the formula if you're one of those that can't do it. You can kind of reconstruct it mentally by doing it in your head. All right, example number 2, go ahead and try this one. Evaluate 7 minus 2j. J starts at 1 and goes to 16. If you want to do it along, you can stop the video and restart it when you're ready. All right, the first term is 5 because j is 1, so plug in 1 for j, get 5. The second term is 3, and the third term is 1. So the difference is -2, and you have 16 total terms. So the 16th term is -25. 7 times the difference, which is -2 times 16. Okay, so our n is 16. Our sum is 5 minus 25, which comes out to -160. All right, so that's how you do this problem. Pretty simple. Okay, plug in the value for n, plug in the first term, calculate the last term, and divide it by 2. So arithmetic sequences, add the first and last term, multiply by the samples, by the value of n, how many terms there are, divided by 2. Now, for a geometric series, there's another pattern that you can observe to find the sum. Suppose this was your series, t1 plus r times t1 plus r squared times t1, which is basically what t3 is, all the way to t1 times r to the n minus 1. If you remember, t1 times r to the n minus 1 is the nth term of any geometric series. Let's multiply the entire series by r. So now our first term becomes t1r, our second term becomes t1r squared, and so on until we get the last term, which is t1 times r to the n. Now if you notice there's a pattern, the second term of the original series matches the first term of the new series. So if we subtract the second series from the first series, all the terms in the middle go away. The t1r cancels, the t1r squared cancels, all the way to t1rn. Even the t1r to the n minus 1 cancels out. So if we subtract, we are left with 2 terms. Sn minus Sn times r equals t1 minus t1 times r to the n power. So what we want to solve for is s of n. So we're going to factor that out of the left. So we have s of n times 1 minus r equals t1 times 1 minus r to the n. We factored out a t1 from the quantity on the right. Now we divide both sides by 1 minus r, and we see that the sum of the series is t1, the first term, times 1 minus r to the n divided by 1 minus r. Now you can reconstruct this no matter what the ratio is if you don't remember the formula. But this does represent the formula of the first n terms of a geometric series with a common ratio r. And this works as long as r is not equal to 1. So again, another formula you need to memorize, but if you've forgotten how to do it, just remember if you multiply the series by r and subtract that from the original series, you can reconstruct this formula by doing it using that approach. All right, let's take a look at example 3. The sum of negative 2/3 to the j power for j is from 1 to 5. So our first term will be negative 2/3. Our second term is 4/9. And this is a geometric series with a ratio of negative 2/3. And you'll know this as a geometric series because you'll see the variable, the number, as the exponent to the ratio. So we need to figure out what the sum is. Now, unlike in the arithmetic series, you don't need to know what the last term is. You only need to know the first term and the ratio. So the first term is negative 2/3. The ratio is negative 2/3. And the n value is 5, the first 5 terms. Now, this looks kind of intimidating. And if you want to simplify it as a fraction, you can. But if you want to express it as a repeating decimal, that's okay too. So S5 is negative 2/3 times 1 plus 32 over 243, all over 5/3. 5/3 represents 1 minus the ratio. 1 minus negative 2/3 is 5/3. Then to get to the next value, the negative 2 times 275 over 243, I multiply the entire fraction by 3. And then I simplify the fraction as follows. So negative 110 over 243. Now we can find the sum of this series. Go ahead and try this one. It's an arithmetic series with a sum with a starting value of 3 and a 10th term of 300, and you want to find the sum of the first 10 terms. So go ahead and try that and start the video when you're ready. All right, so you're going to use the arithmetic sequence formula, which is 10, the number of terms, times the first term plus the 10th term, 3 plus 300, all divided by 2. So you see that the sum is 1515. Okay? Looking at example 5, find the sum of this series. 50 plus 33 plus 16, all the way to adding negative 86. Now this is an arithmetic series. The difference is negative 17. The problem is we don't know which term negative 86 is. It doesn't tell us. So we need to figure out what the value of n is. So if you solve for n, you see that the first term is 50, and we know the difference is negative 17. So what we can do is solve for n by using the formula for the nth term of an arithmetic series. Tn equals t1 plus d times n minus 1. So we plug in negative 86 for the nth term, 50 for the first term, negative 17 for the difference, and we're going to solve for n. So if you solve for n, you see that n is equal to 9. Now, if you do this problem and your n is not a round integer, something went wrong because obviously you cannot have a 7.6 term of a series. So now you use the sum formula, the series formula. Now you know n is 9. The first term is 50. The last term is negative 86. You're going to take that value and divide the whole thing by 2. And your total sum is negative 162. So if you don't know the number of terms, you'll have to figure out how many terms are by using the formula for the nth term of a series. Let's go to number 6, a geometric series with n equals 10, r is 2, t1 is 1/4. Again, I would encourage you to try this on your own and then restart the video when you're ready to see your answer. All right, so the sum, this is a geometric series, so the first term is 1/4, so that goes over here with the 1/4, times 1 minus r to the n. So 1 minus 2 to the 10th power, all divided by 1 minus r, which is 1 minus 2. So if you simplify this and do some arithmetic, you see that the sum is 255.75. Looking at example 7, find the sum of the first 8 terms for 48 minus 24 plus 12 minus 6. So the first thing you want to figure out is this arithmetic or is this geometric? Well, if you take a look, each time you are multiplying the previous term by negative 1/2 to get the subsequent term. So this is a geometric series. We know there are 8 terms, so we're going to use the formula for the sum of a geometric series. N times 1 minus r to the n, all over 1 minus r. So first term is 48, 1 minus negative 1/2 to the 8th, all over 1 minus negative 1/2, which is 1 plus 1/2. So if you crank that out, do the math, you get an answer of 31 7/8. Again, if you use decimals, that's fine. Just make sure you note any repeating decimals, 31.875. All right, I would like you to try numbers 8, 9, 10, 11. It's basically the same type of problems. You're just determining whether a sequence is geometric or arithmetic. If it's geometric, you got to know the ratio in the first term. If it's arithmetic, you got to know the first term, the last term, and the number of terms. So go ahead and do 8, 9, 10, and 11. 10, 11 are word problems. Give those a shot and restart the video when you're done. All right, number 8, we are looking at the first 100 terms. The sum of 2k minus 51. The first term is negative 49. If you plug in 1 for k, you get negative 49. The 100th term, well, we'll get to that in a second, but the difference is negative 2. So you'll notice, the difference is 2. You'll notice that the slope, the arithmetic sequence or series always is expressed as a line, and the slope is the common difference. So here, the slope, or the d value, is 2. So the 100th term is negative 49 plus 99 differences, which comes out to 149. So we're going to plug it into the sum of an arithmetic series. We know the number of terms is 100. We know the first term is negative 49. We know the last term is 149. We divide that entire product by 2, and the sum is 5,000. Example 9. We are looking for the sum of the first 9 terms of the geometric series, 640 times negative 3/2 to the n. How do you know it's geometric? Because geometric series they look like exponential functions. So n is in the exponent, negative 3/2 is the ratio. So the first term is 640 times negative 3/2 of the first, which comes out to negative 960. Remember, to find the sum of a geometric series, you need to know the ratio, you need to know the value of the first term. Our ratio is negative 3/2, so you plug it into the formula, and this is where you want to use your calculator. The calculator is your friend, but make sure you enter the numbers and the fractions in correctly so you don't get some weird number. All right, so you put all those in. I factored out a negative 384. You don't have to do that. You can just let your calculator do the work. You get negative 60,585 over 4, which also is the same as negative 15,146.25. So the key with some of these geometric series is that the sum has to be entered into the calculator correctly to get the right answer. Otherwise, you're going to have some wayward numbers. All right, got some word problems. Number 10, a hose is coiled so that each complete loop is 6 inches longer than the previous loop. If the innermost loop is 18 inches long and there are 15 loops in all, how long is the hose? So the first thing you want to figure out is, what kind of series is this, geometric or arithmetic? Well, we know the first term is 18. Each loop is 6 inches longer than the previous loop. So what's the second loop? Well, it's going to be 6 inches longer, which means the difference is constant. The d value is 6. So the 15th loop has a length of 18 plus 6 times 15 minus 1, which comes out to 102 inches. So once you figure out that it's an arithmetic series, you figure out the difference, you figure out the number of terms, and you figure out the last term. So the sum is 15 times the first term of 18 plus the last term of 102 divided by 2 comes out to 900 inches long, or 75 feet. Finally, number 11, the Thompsons paid $300 for electricity during 1985. If their costs increased 10% each year thereafter, how much did they pay for electricity between 1985 and 1990 inclusive? So, when you see an increase by a percentage, that's a clue to tell you it's a geometric series. It's an exponential function. So the first term here is 300. That's how much they paid during the first year. The second year, it increased by 10%. So you have to multiply the previous term not by 10%, by 110% to reflect the increase of 10% plus the amount they paid the previous year. So the ratio is 1.1. And the sum for 6 years, because 1990 would be the 6th year if 1985 is the first, and you get 300 times 1 minus r to the n, which is 1.1 to the 6th, all divided by 1 minus r, which is 1 minus 1.1. So again, put those into your calculator carefully, and you get an answer of $2,314.68. So the key for arithmetic and geometric series, you have to identify what kind of series it is, memorize the formula, or be able to reconstruct the formulas using one of the approaches that we use to come up with the formula, and then plug in the terms you need. So you're going to have to go back and remember how you solve for the nth term of an arithmetic sequence, how to find the number of terms using n if you know the first and last term, and for a geometric series, you need to figure out how to calculate the ratio. That's it for section 11-5. Tomorrow in class, you will get the homework assignment. See you later.